Hi, welcome to our electrolysis lesson. My name is Miss Rowe and I will be introducing the topic for you today. Electrolysis is one of those things that we don't even notice that it's a part of our life. From costume jewelry to the production of aluminium, it is a very important process. So, without much ado, let us get right into it. What are we going to learn today? We're going to start off by defining the term electrolysis. Then we are going to be stating the parts of the electrolytic system. We've got a diagram up here that kind of shows it. We're going to be defining the terms that are related to electrolysis: electrolyte, electrode, anode, cathode, ion, and cation. We are also going to be describing what happens in the process of electrolysis. Are you ready for it? Stay tuned. So, what is electrolysis? Now, looking at the word electrolysis, is there any part of that word that is familiar to you? Is there anything that you think that you could link that word to that's a part of your everyday life? I'll pause and let you think about it. Was this the word that you had in mind? Electro, which is the first bit of the word electrolysis, is related to the word electricity. What about lysis? Have you ever heard of that term before? Do you know what it means? Lysis refers to breaking down or breaking apart or separating. So that means that electrolysis is going to be us using electricity to break down or to break apart something. In this case, thing that's going to be broken down or broken apart is going to be the electrolyte. Now, if you look at the diagram that is directly below, you're going to notice that that container has some liquid in there. And the liquid that is in that container is our electrolyte. So what we do in electrolysis, we are going to be passing a direct current through that liquid, and it is going to cause a separation or a breakdown of that liquid into its individual ions. Now we know what electrolysis is. Let us look at the parts of an electrolytic cell. Now we've mentioned the electrolyte already. We are now going to be looking at the power source and the electrodes as well. Now the power source is going to be providing the electrical energy for the circuit. This right here is a common power source that we use for remotes at home, and in a similar fashion it is going to be providing electricity or electrical energy for our electrolytic cell. Now connected to our power source, we have two rods, which are our cathode and our anode. The cathode is the negative electrode, and it is going to be connected to the negative terminal of the power source, right? This is going to give it a negative charge. The positive electrode, which is our anode, is going to be connected to the positive side of our power source, and that is going to give that rod a positive charge. Now both rods are suspended in the solution, which is our electrolyte. Now your electrolyte is an ionic compound that is either dissolved in water to make it a solution, or we have melted it to make a molten version of it. And the reason for having it in solution or melting it is to make sure that the ions that are in that ionic compound become mobile, making them free to move around. which is going to be important. Quiz time. Now, do you think you can remember the names of the parts of the electrolytic cell? Now, I know this diagram is different from the diagram that you had before, but the parts are the same with a little challenge added to it. So you can pause the video at this point for as long as you want and see if you can remember the parts. So, how well do you think you did? Here it goes. You can check your answers. So this is the power source or the battery. Our positive electrode is our anode, and attached to our positive electrode are our negative ions that we call anions. So get it, anode and ion, anode and ion. See the similarity? On the other side, we have our cathode, which is our negative electrode, and attracted to our cathode will be our cations. Cathode, cations, cathode, cations. See the link? And this takes place in the presence of our electrolytic solution, which is called our electrolyte. Did you get them right? So, how does this thing work? Now, we're using molten sodium chloride as our example for this electrolysis. Now, molten means that we have melted the compound, and sodium chloride is an example of an ionic compound. Now, what that means is that the compound is made up of positive metal ions and negative non-metal ions. When we switch on our electrolytic cell, we cause the two rods to become charged. One side becomes negative and the other one becomes positive. Now, our positive metal ions that are present in our electrolyte, in this case, our positive ion is sodium. It is going to be attracted to the negative electrode. When it gets there, it is going to receive electrons from that negative electrode, causing it to move from being a metal ion to being a metal atom. Our non-metal ions are going to be moving from the solution and they're going to be attracted to our positively charged anode. When they get there, they're going to give up their electrons to the anode, and that's going to cause them to form, guess what? Non-metal atoms. Now, the thing about the non-metal atoms is that they tend to bond together and form simple covalent molecules. So, activity time. Now, do you think that based on the example that we have done before, you'd be able to predict the products that would be formed from the electrolysis of these three ionic compounds? You can pause the video and try to figure it out. So, how well do you think you did? Were these your answers? Now, aluminium, lead, and calcium, they are positive ions, so they would have been attracted to the negative electrode. The electrode would have donated electrons to them to allow them to form metal atoms. At the anode, or oxide, bromide, and chloride ions would have moved. They would have been attracted to that positive electrode, and when they got there, they would have given up or donated their electrons to the electrode, and they would also form atoms as well. So if you got them right, good job. We have come to the end of our lesson. Do you think that you can match the parts of the electrolytic cell with their descriptions? Pause and find out. And here are our answers. I hope that you learned something today, and thank you for watching.